Hello, this is Mr. Collier, and today we're doing some harder arithmetic sequence examples. So in the first sequence, we know it's an arithmetic sequence, so we know that it has a common difference. So one way to approach this problem is we know that 13 minus 9 has to be equal to 9 minus k. And we can solve this little equation. This is going to be 4 equals 9 minus k. Subtract 9 from both sides. We get negative 5 equals negative k, so k equals 5. The second example, we can approach it the same way. We can say negative 3 minus k equals k minus 3k plus 1. And then simplifying, we get here k minus 3k minus 1. And we're going to simplify a bit more. We got k minus 3k is negative 2k. And now to solve this, you want to add 2k to both sides. This is negative 1k and negative 2k. We add the 2k to both sides of the equation. And we get negative 3 plus k equals negative 1. And then we add 3 to both sides. We get k equals 2. And we can check that. Let's check to see if that's right. Our terms in the sequence are 3k plus 1, k, and negative 3. But k is 2. So we could do 3 times 2 plus 1 gives you 7. K is 2 and negative 3. We can check to see if that's an arithmetic sequence. So here we have to add a negative 5 and then add a negative 5 to get the next term. So it is an arithmetic sequence. So it looks like we did it correctly. The next example, we've got the 6th term and we've got the 11th term. So we've got a bunch of blanks. We don't know what the first terms are. But we do know that U6 is 25. And then we've got U7, 8, 9, 10. U11 is 40. So we need to look at this and, well, first of all, the question is asking for the general term U sub n. So we're looking to find the formula U sub n equals U1 plus n minus 1 times the common difference. So we need to find these two things. We need to find U sub 1 and d. So one way to approach that is, in order to get from 25 to 40, you have to keep adding the common difference, which is d. And how many times are we going to do that? Well, from 6 to 11, we have to add d 5 times. So you can set the equation 25 plus 5d equals 40, and then solve for d. So we get 5d equals 15, and divide by 5, we get d equals 3. So we're partway there. We have the d value, which equals 3. Now how do we find the u sub 1 value? There's a couple ways to do that. One way is we can pick one of our original terms here. So u sub 6 is 25. So you can say 25 equals u sub 1 plus, now we pick in u sub 6, so that means the n value is 6. And the common difference is 3, and we can work this out and solve for u sub 1. So that's going to be 15. We subtract 15 from both sides, and we get u sub 1 equals 10. So we have those two things, and now we just need to write the formula, which is u sub n. Let me try to use a different color. U sub n equals u sub 1 plus n minus 1 times d. And we know that u sub 1 is 10 and d is 3, so we need to simplify this. We get 10 plus 3n minus 3, and 10 minus 3 is 7, so we have 3n plus 7 is our formula for the general term. Okay, one last example. In here, we want to insert 4 numbers between 3 and 12 to make a arithmetic sequence. So we have 3, then we have 4 numbers in between, and then 12. So we want to insert numbers to make an arithmetic sequence. So the thing about an arithmetic sequence is you're always adding the same common difference. And how many times are we doing that? We're doing that 5 times. So this means that 3 plus 5d equals 12, and solving we get, well, we subtract 3 from both sides. 5d equals 9, and d equals 9 out of 5, which equals 1.8. So we're going to add 1.8 to each term to complete the sequence here. So 3 plus 1.8 is 4.8. Add 1.8 again, we get 6.6. Add 1.8, we get 8.4. We add 1.8 again, we get 10.2. And just to check, if you add 1.8 again, you get 12. So it seems that we've done it correctly.